we need to complete a Venn diagram, and we're told that E, our universal set, everything we're putting into the diagram, is all even numbers between 1 and 21. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. We're told set A is 2, 6, 10, and 18. So in the A circle, we're going to put 2, 6, 10, and 18. B is 4, 10, 12, and 18. So in the B circle, we're going to have 4, 10, 12, and 18. In the middle, in the intersection between A and B, we're going to put the numbers in both of them. So they both have a 10, so that goes in the middle, and they both have an 18, so that goes in the middle. Then what other numbers are in A? What other numbers go in the A circle? We want 2 and 6. And what other numbers are in the B circle? We want 4 and 12. But remember, we wanted all even numbers between 1 and 21. So some numbers are going to go on the outside. So we've got 2, 4, 6. We need 8 on the outside. We've got 10, 12. We need 14 and 16. We've got 18 and we need 20. So this is our Venn diagram completed. Now we've got questions. It says a number is chosen at random from the universal set E. So one of these numbers is picked at random. Find the probability it's in the set, the union of A and B. That means it could be an A or B or both. It's within the circles. So the probability, it's one of the numbers within the circles. So how many numbers are within the circles? We've got 6 numbers inside the circles, 6 numbers in the union of A and B, out of 10 numbers in total. 6 inside the circles and 4 outside. So the probability that a number picked at random is in the union of A and B is 6/10. We could simplify that, but we don't have to. The second question, the next question, says find the probability the number is in the intersection of A and B, is in both the A circle and the B circle. So there are 2 numbers in both circles, 10 and 18. They're the only ones that are in both A and B. And there are 10 numbers in total. So the probability is 2 out of 10. Again, we could simplify, but we don't have to. Okay, here's one for you to try. So pause the video and try and give this a go. So this time we've got all odd numbers between 0 and 20. We're told set A is 1, 5, 9, 11, and 19. And set B is 3, 5, 7, 13, and 15. So complete the Venn diagram. So in the intersection, we're going to put the numbers in both. So we've got 5 in both of them. And there is no other number in the intersection. So just 5 is in the A circle and the B circle. And then also in the A circle, we want 1, 9, 11, and 19. And in the B circle, we want 3, 7, 13, and 15. Do any numbers go outside? So we've got all the odd numbers between 0 and 20. So 1, 3, 5, 7, 9, 11, 13, 15. We don't have 17. So 17 is on the outside. So again, we've got 10 numbers, and there will be 10 odd numbers between 0 and 20. So let's answer the questions. So find a number is chosen at random again. Find the probability that's in the union of A and B. So the union of A and B means it can be in the A circle or the B circle or in the middle or in the intersection. So how many numbers are inside the circles? There are 9 out of 10 in total. So the probability it's in the union of A and B, so in the A circle or the B circle, is 9/10. Find the probability it's in the intersection of A and B. There's only one number in the intersection of A and B, in A and B. So it's one number out of 10 in total, so 1/10. Okay, another question. This time we've got 3 circles, but we're doing the same thing. So we want all odd numbers between 0 and 30. That's everything. That's our universal set. So A is 1, 3, 9, 11, 17, 25, and 29. B is 3, 5, 7, 13, 15, and 17. And C is 3, 5, 7, 13, 21, 25, and 29. So in the middle of all 3 circles would be anything that's in A, B, and C. And they've all got a 3 in them. So they've all got a 3. Have they all got anything else? So they haven't all got a 5 or a 7 or a 9. They haven't got an 11, a 13, a 17, a 25, or a 29. So only 3 goes in the middle. And then in between the A and B circle is going to be anything else that A and B share. So A and B have both got a 17. So 17 is in A and B. And there's nothing else that they share. How about B and C? So B and C have both got a 5, a 7, and a 13. So B and C have got 5, 7, and 13. There's nothing else that B and C share. And A and C have both got 25 and 29. So what else goes in A? 1, 9, and 11. What else goes in B? It's just 15. And in C, we want 21. Are there any numbers on the outside? So we've got 1, 3, 5, 7, 9, 11, 13, 15, 17. We don't have 19. 19 wasn't in any of them, so that goes on the outside. 21. We don't have a 23 in any of them. We've got 25. We don't have a 27, but we've got 29. So there should be 15 numbers here, so let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So a number is chosen at random again. Find the probability that it's in. So what's this mean? It means not A. Find the probability it's not in A. So how many numbers are not in the A circle? 1, 2, 3, 4, 5, 6, 7, 8 out of 15 in total. So there should be 7 inside the A circle. 1, 2, 3, 4, 5, 6, 7, which means there's 8 on the outside. Find the probability of A and B, the intersection of A and B. So where do the A and B circles intersect? That's this bit here, the intersection of the A circle and the B circle. There are 2 numbers in there, so the probability is 2 out of 15. And one of these for you to try, so give this one a go. So this time we want all even numbers between 1 and 31. In the middle, the A, B, and the C circles is any numbers that's in all of them. So we can see they don't have 2, 4, 6, 8, 10, 12. They've all got 14. They don't all have 16. They don't have 18. So that's it. They've all got 14 in them. Let's look at A and B. So they've both got a 6. and that's the only thing that A and B have got in common. Let's look at B and C. So they're both got 18. So between B and C, we want 18. And that's the only thing they've got in common. And A and C don't have anything in common. So they're all the intersections. So what else is in A? We've got 2, 10, 26, and 30. 2, 10, 26, and 30. In B, we've got 4, 16, and 24. And in C, we've got 8, 12, 20, and 22. So are any numbers missing? We've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, and we don't have a 28. So 28 goes on the outside. It was even numbers between 1 and 31. There should be 15. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's our Venn diagram. Let's look at the question. Find the probability. So a number is chosen at random. We want the probability. It's in the union of A and C. So either in the A circle or the C circle or both. So let's count the numbers in the A circle and the C circle. So that's the A circle. Anything inside the A circle. And anything inside the C circle. So all the numbers in these two circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 out of 15 numbers in total. And find the probability that it's in the intersection of A and B. The intersection of A and B. There are 2 numbers in the intersection of A and B. So it's 2/15. Here's a different question. This time we've been given information about the number of people that like tea, coffee, and hot chocolate. And we need to complete a Venn diagram to show the information. So this time the numbers in the circles are going to represent how many people go in that category. So with these questions, we need to start in the middle and work our way out. So we're told 15 people like all 3 drinks. So we're going to put 15 people. So this 15 means 15 people. And they're going to be in the tea circle, the coffee circle, and the hot chocolate circle. So 17 like tea and hot chocolate. So the intersection of tea and hot chocolate is going to be 17 people. But there's already 15 in there. So we need 2 more. That's why we start in the middle and work out. So the intersection of tea and hot chocolate is 17 people. 15 people that like coffee as well. And 2 people that just like tea and hot chocolate. 18 like tea and coffee. So the intersection of tea and coffee needs to be 18. Again, we've already got 15. So 18 take away 15 means we need 3 more. 11 like coffee and hot chocolate, but not tea. So that's 11 here. They like coffee and hot chocolate, but not tea. 35 like coffee. So the whole coffee circle is going to be 35 people. So how many do we have so far? 15, 11, and 3 is 29. We need 35, so we need 6 more. 30 like hot chocolate. So how many do we have so far? 15, 11, and 2. That's going to be 28. So we need 2 more in hot chocolate. And 2 do not like any of the drinks. So 2 go on the outside. But we've got a gap here. So we need to use that there were 50 people in total. So we can say the coffee circle was 35 people. So that circle is 35 people, and we've got 2, 2 and 2 more. So we've got 41 people so far. There are 50 people, so 9 must like tea only. And to finish up, we've got one of these for you to try. So pause the video, give this one a go, and press play when you're ready for the answer. So we've got 100 people this time, and it's either rugby, football, or cricket. We're starting at the middle, and we're going to work our way out. So we're starting with 18 people, like all 3 of the sports. We've got 25 like rugby and football. We've already got 18 that like rugby and football, so we need 7 more. 22 like rugby and cricket. So we've already got 18. We need 4 more. 20 like football and cricket. We've already got 18. We need 2 more. 52 like football. So far, our football circle is, well, 18 and 2 make 20, plus 7, 27. So how many more do we need? 52 take away 27 is 25. So 25 just like football. 35 like cricket. So at the moment we've got 24. 35 minus 24 will be 11. And 45 like rugby. So far we've got 18 and 7, which makes 25, plus 4, 29. So 45 take away 29 is 16. So 16, just like rugby. Are we finished? Well, there might be some on the outside that don't like any. So let's add up what we've got. So let's start with our football circle. So the whole football circle was 52 people. Then we've got 16, 4 and 11. So 16 and 4 make 20, plus 11 is 31. So we've got 83 people so far, which means there must be 17 on the outside.